Imagine a box. Inside this box is a particle detector, a loaded gun, and you. The gun's firing mechanism is wired to the detector, which is waiting to measure the spin of a single electron. If the spin is measured as up, nothing happens. If it's down, the gun fires. You press the button. Before the measurement occurs, quantum mechanics states that the electron does not choose a direction. It exists in a state of superposition, occupying both up and down states simultaneously. Because the particle remains in both states, the universe does not select a single outcome. It splits to accommodate every possibility. For an outside observer, there is a branch where the gun fires and you are gone. But you cannot experience your own absence. From your internal perspective, the only reality you are capable of perceiving is the one where the gun clicks empty. Quantum immortality is the literal mathematical endpoint of this logic. It describes a scenario where the laws of physics forbid an observer from experiencing their own end. This paradox is built on the double-slit experiment, providing the physical evidence that reality does not behave like a series of solid, predictable events. When fired at a two-slit barrier, electrons act like waves, passing through both at once to create an interference pattern. But if a detector observes their path, the wave behavior vanishes. The electron acts like a single particle, leaving two distinct marks. For most of the 20th century, the Copenhagen interpretation was the standard explanation. It claimed that the act of observation magically causes the wave of possibilities to collapse into a single definite reality. But the wave function, first written down by Erwin Schrödinger, contains no physical mechanism for this collapse. Mathematically, there is no reason for the other possibilities to simply disappear. In 1957, Hugh Everett proposed that we take the math at face value. He argued that the wave never collapses. In Everett's many worlds interpretation, the observer becomes part of the quantum system. Instead of possibilities vanishing, the universe branches, creating separate, equally real versions of reality for every possible outcome. We don't see these parallel worlds because of decoherence, the mechanism separating the quantum world from our daily experience. As a quantum system interacts with its environment, different outcomes drift out of phase. The branches become permanently sealed off from one another. This branching has been happening continuously across the entire cosmos since the Big Bang. If you want to explore the specific branch of reality where we untangle these mysteries, subscribe to the channel. Once decoherence occurs, the separation is absolute. Every version of you continues their life in a timeline that can never again interact with the others. Returning to the box, we can now clearly see what this branching structure implies for the fundamental nature of human consciousness. In a split-second event, one version of you dies while another survives, but you cannot experience the state of being dead. Because subjective awareness requires a functioning brain, your stream of consciousness has no choice but to follow the branch where the hardware is still running. David Lewis called this the corrected intensity rule. Subjective survival is the only outcome you can record. But in the real world, threats to life are rarely instant, binary quantum measurements. Car crashes, heart attacks, and diseases are slow, complex processes. If the math literally forbids you from experiencing your own cessation, it forces your awareness down the most improbable pathways. You would find yourself in the 1 in a trillion reality where the car swerves just enough, or the cancer cells fail to replicate. In this framework, you are trapped in a probability prison. You are forced to inhabit the absolute margins of survival, no matter how much damage the rest of your body has sustained. This leads to the Struldbrugg effect. Surviving infinite dangers means accumulating infinite physical deterioration. You would eventually outlive your loved ones and your own mental faculties, becoming trapped in a failing body that the math refuses to let go. The question is whether this purely mathematical consequence actually reflects how human consciousness works. The many worlds interpretation treats the mind as a passive observer of the math. But modern physics suggests the you inside your head may be more complex than a passenger. Finding the exit to this quantum trap requires looking beyond probability and into the laws of thermodynamics and atomic organization. To understand what happens when you die, we must define what you are made of. And as we will discover in Part 2, the answer is etched deeply into the very geometry of the universe. When was the last time you died? It sounds like a question for a preacher, but if you look at the physical atoms currently making up your body, the you from last year is gone. You are a collection of 7 octillion atoms, and those atoms are constantly in motion. You eat a potato, the atoms get broken down and built into your tissues, while your old cells are exhaled as carbon dioxide or flushed away. Physicist Richard Feynman used a candle to explain the reality of this constant exchange. Light a candle and watch the flame burn for an hour. The wax appears to disappear, but the first law of thermodynamics states that matter and energy cannot be destroyed. Those carbon and hydrogen atoms simply combined with oxygen and floated away as vapor. Every atom of that candle is still drifting through the atmosphere. It has only changed form. This conservation applies to you. Every atom in your body was here before you were born. The carbon in your muscles was forged in the nuclear furnace of a star that lived and died billions of years before the Earth formed. When those massive stars collapsed, they triggered supernova explosions so violent they briefly outshone entire galaxies. These explosions scattered the elements across the cosmos, eventually condensing into the soil, into the plants, and the people we see today. Because atoms flow through us like water through a stream, a human being is not a permanent object. You are a temporary configuration, a wave that matter briefly moves through as it follows its own path through the universe. From this perspective, death is a reorganization. One specific pattern ends, and the components disperse to create new ones. Matter is conserved. The dance simply changes partners. If our physical building blocks are constantly being replaced, we have to ask what maintains the continuous experience of being you. Classical biology long assumed the brain was too warm and wet for the delicate interactions of quantum mechanics to occur, but evidence of quantum effects in living systems is mounting. European robins navigate using Earth's magnetic field through quantum entanglement in their retinas, suggesting that biology can and does utilize quantum signals at body temperature. This realization led Stuart Hameroff and Sir Roger Penrose to propose the ORCOR theory. They argue that consciousness is not a product of neural computation, but a quantum event happening within the cell. Inside every neuron are microtubules, protein tubes that vibrate at quantum frequencies. These structures may serve as the hardware that allows the brain to process a consciousness that exists beyond simple chemistry. In 2023, Jimo Borjagan studied the brains of patients during cardiac arrest. Moments after their heart stopped and blood flow ceased, she recorded massive surges of organized gamma-wave activity. Standard neuroscience models cannot account for this. A dying, oxygen-deprived brain should not be capable of producing coherent, high-frequency oscillations associated with heightened conscious experience. This suggests the brain functions as a receiver for an external signal. The gamma surge recorded at death may be the result of the biological antenna breaking down, allowing the full signal to flood in as the filters of the living brain fail. If consciousness is a quantum process, its fate is tied to the no-deletion theorem. This theorem dictates that quantum information cannot be erased from the universe. It can be scrambled, transferred, or redistributed until it is unrecognizable, but the laws of physics state that it cannot vanish. Albert Einstein's theory of relativity provides the physical framework for where this information resides. In Einstein's block universe, time does not flow. Past, present, and future exist simultaneously as fixed coordinates. We experience time sequentially, like a needle reading a vinyl record. When we die, the needle lifts, but our quantum information remains permanently etched into space-time. Every action you have taken and every choice you have made is locked into this structure. The information is carved into the fabric of reality, immune to the decay of time. Physics suggests that you are not a temporary event, but a permanent coordinate in the universe. If you cannot be deleted, the question is what kind of life you are etching into the fabric of eternity.